All right, IBSL1. Today we're going to talk about inverse functions. So the inverse of a function, first of all, the notation for it is f to the negative 1 of x. That is not an exponent. It's just a notation thing that says that this is the inverse of f. Now, if a function and its inverse are composed with each other, so remember here we're using this composition symbol. If you compose f with its inverse, you should get just x. So f's inverse should be x, but also the reversal of that you can go this direction, f of f's inverse, and you can take f's inverse of f. That should also be equal to x. This will happen anytime you have a function and its inverse. So another way to say this is that if you have f of x and g of x, they will be inverses of each other if and only if fog of x and gof of x are equal to just x. It should be noted that in order for a function to have an inverse, it must be a one-to-one function. So what that means, a one-to-one function, each input has to have its own unique output and vice versa. Each output has to have its own unique input, which means it must pass a vertical and a horizontal line test. So we have not talked about horizontal line tests yet, but now if a function only has an inverse if it's a one-to-one function and it passes both the vertical and horizontal line test. First problem, we're going to use composition of functions to show that f of x equals 2x plus 4 and g of x are inverses of each other. So if they're inverses of each other, we have to check f of g of x and also g of f of x. Both of these should be equal to just x. So you're up a little line in between them to keep track. F of g of x is taking g of x and putting it into the input for f of x. So this is 2 times x minus 4 all over 2 plus 4. Then this 2 and this 2 cancel each other out. So we get x minus 4 plus 4. And then the minus 4 and plus 4 cancel each other out and we get just x. So f of g of x is equal to x. That's a good sign because that should happen when f and g are inverses of each other. But it's not enough just to check one side of that or one direction of f of g of x. We also need to check g of f of x. So that means taking f of x and putting it into g. So we'll put 2x plus 4 right here, subtract 4 all over 2. Now those parentheses are kind of unnecessary, so we'll drop those and just say 2x plus 4, take away 4, divided by 2. Then the 4 and negative 4 cancel each other out, so we're left with 2x over 2, and then 2 divided by 2 is 1. So g of f of x is equal to x. That's another check. This means f of x and g of x are inverses of each other. Oh gosh, that went off the rails. The way you don't want to do that problem, if I say use composition of functions to show that these two are inverses of each other, sometimes I'll see students just take one of these and then find the inverse of that function and then be like, look, it matches that one, Mr. Jolly. But that's not using composition of functions. So make sure you follow the directions at all times. So determine if each function below is a one-to-one function. If so, find its inverse. With all of these, well, first we'll check if it's a one-to-one function, but then I'm going to show you guys how to find an inverse algebraically. So the steps are change f of x to y. Then we are going to switch x and y. Then we will solve for y. get it by itself, and then change y into inverse notation. So first they ask, is this a one-to-one function? Well, if you picture this on a graph, it starts at 2 and then goes up 4 over 1, up 4 over 1. So it looks something like this. This does pass a vertical and a horizontal line test, so it has an inverse and we can find it. First step, make it y is equal to 4x plus 2. Second step, switch the x and the y. Then get y by itself. So we're going to have to subtract 2 from both sides, divide by 4, and then change it into inverse notation. So f to the negative 1 of x, the inverse of f, is x minus 2 all over 4. That's it. Swap the x and the y, get the y by itself. Now, first they want to know, is this a one-to-one function? If I go to graph this, it's a parabola that's been shifted up by 1. So if we go up 1 here, it looks like this. Now, this passes a vertical line test. Like if I put a vertical line through here, it only touches once, but it fails a horizontal line test. It touches twice on a horizontal. So this is not a one-to-one function. Therefore, it has no inverse. I guess we should say inverse function. It has no inverse function. That's that one. Now, is this a one-to-one function? If you sketch it up on your calculator, I think it looks something like a space dolphin that went 2 to the left and 3 down, something like that. Like this. So this passes a vertical and horizontal line test, so yes, it's a one-to-one function. To find the inverse, we will write it as y is equal to the square root of x plus 2, take away 3, then switch the x and the y. Then I will add 3 to both sides. Then I will square both sides to get rid of the square root. So we'll do x plus 3, quantity squared is equal to y plus 2. Then subtract 2 from both sides. So g to the negative 1 of x is equal to x plus 3 squared, take away 2. You might look at this part and be like, should I FOIL that out and then combine like terms? I don't think that's completely necessary right now unless they said to do that in the directions. Another one, h of x goes to x minus 1 cubed minus 2. Let's not forget that this funky notation just basically means h of x. Now, if you graph this, I think it looks something like, it's like a chair function that goes 1 to the right and 2 down. So I think it looks something like this. Which this is a one-to-one function because it passes a vertical and a horizontal line test. Which means we can find the inverse. So if you write it as h of x equals x minus 1 cubed minus 2, then you make this y, and then switch your x and your y, and get y by itself. We're going to start by adding 2 to both sides. Now, to undo a cube, I have to do a cube root. Nope, that doesn't work. Where this will be x plus 2, but then in this little cradle, I have to put a little 3 to denote that that is a cubed root. And then I have to add 1 to both sides. I cannot get that under control, sorry. So, h to the negative 1 of x goes to cube root x plus 2 plus 1. There it is. For each function, sketch its graph on the same set of axes. Sketch the graph of its inverse. Well, I guess we'll start by graphing the original function. So I'm going to graph negative 2x plus 2. That's a linear equation that starts at positive 2 and goes down 2 over 1, down 2 over 1, down 2 over 1. So it looks something like this. So I'll label it. This is f of x. Now let's go ahead and find its inverse. So you switch your x and your y, and you get x equals negative 2y plus 2. Subtract 2 from both sides. Divide by negative 2. And then I actually am going to split this up into y equals mx plus b form. So this will be, well, 2 moves at once. F to the negative 1 of x equals negative 1/2 x plus 1. That's because you're dividing the x by negative 2 and dividing the negative 2 by negative 2, which is positive 1. So this inverse equation starts at positive 1 and then goes down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. Let's see if we can connect these with a line. Something like that. Yeah, so that's the function and its inverse on the same graph. There is a relationship that's happening between them, but maybe it'll become more evident after our next problem. All right, it's a parabola, but its domain is only for positive numbers. So if I was to graph this parabola, it's an upside down parabola that's been shifted up 4. So if we got 1, 2, 3, 4, it would look something like this. But since it is only true for x is greater than 0, I mean, it has a restricted domain, that means that we're actually going to get rid of this part right here. It's only for positive numbers. So they're doing this because now it's a one-to-one function. Before it was not a one-to-one function because it failed the horizontal line test. So now it's one-to-one and we can find its inverse. So I'll say x is equal to negative y squared plus 4. That's me already switching the x and the y. Now I got to get the y by itself. So we subtract 4 from both sides. Divide by negative 1. Square root. So the inverse is the square root of negative x plus 4. That's it. So, if you graph that on your graphing calculator, it will look like this. it is a space dolphin that jumps out here at 4, 0, and the original parabola starts at 0, 4. So notice with these two spots that the x's and y's have switched positions. That's going to be true of every single function and its inverse. All the points on the original, if you switch their x's and y's, you get all the points of the inverse, which makes sense because our very first move on all of this is to switch the x and the y's. So the graphical relationship between these two things is that they are reflected across the line y is equal to x. So, big idea there about functions and their inverses and their graphs, which I think is also true if you scroll back up to this guy right here. Like if you were to draw in the line y is equal to x, like notice if you were to take this piece of paper and like fold it over the red line, that everything on this upper left half would match up perfectly with everything over here. All right, that's all I got for you.